Hello everyone, I'm Frank and welcome to Frank Puzzles. And this is today's easy Ichikara puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Torque by Michael Lefkowitz, and here are the rules. We have Ichikara, which means we need to divide the grid into regions, where a region contains the numbers from 1 to n once each, where n is the largest number in the region. And the region must be an orthogonally connected region, where basically to get from any cell in the region to any other cell in the region, you can just do it by going through edges. So this would be a valid region because it would be orthogonally connected, because you can go from any cell in that region to any other cell in the region just by going through edges, all while staying within the region. That's the reason why this is a valid region. This, however, is not, because this cell does not connect to the rest of the other cells in the region just by going through edges and staying within the region. It would either have to go through a corner or would have to go outside of the region for this to work, which is not allowed. And again, this also, even though this is valid as a potential region, it's not actually valid as an actual region because it doesn't contain the digits 1 to n once each. It has a duplicate here, so that's not allowed. So you are not allowed duplicates in a region. This would be a valid region if we remove the 2, because without the 2, we have the digits 1 through 3 in the region, which is valid. This would force it to have the digits 1 through 3, but then a second 2 would be in that region, which is not allowed. Also, regions may also contain empty cells. So that's another kind of assumed in this, but you can have blank cells within any region too. And those are the rules of Ichikara. And here, well, that's it. And if you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, what I like doing for Ichikara puzzles is count how many of each digit we have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 ones. How many 2s do we have? Let's start from this way because then we can get potentially more space. 2s. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 2s. 3s, we have 4 3s. 4s, we have 3 4s. 5, we have 3 5s. 6s, we have 2 6s. We should have 2 of the remaining digits, right? 2, 7, 8s, and 9s. So that means in total, so every set, so we have 2, 2, and 2, and 2 for the digits 6 through 9. That means all of these 2s for 6, 7, and 8 must be used by the 9 regions, right? Because we only have 2 of them available. Every 9 region must have the digits 1 through 9 in their region. So that means we have 2 9 regions. We have 1 5 region. We have 1 3 region. And we have 7 2 regions, which means the digits 1 and 2, and then 2 1 regions. So we have for regions of size 1, we have 2. For regions of size 2, we have 7. For regions of size 3, we have 1. No. Yeah, it's 1. For regions of size... Actually, no. Yeah, we have 4 3s. We have 3 4s, right? So for 3, we have size 1. We have 1 region of size 3. We have 1 region of size 5. And we have 2 regions of size 9. And those are the regions we have. Okay. This 9 is surrounded by 1, 2, and 3. So you have to go through a 1, 2, or 3 to get to the rest of the puzzle. This 8 is surrounded by 1, 2, and 4. So to get through this 8, we need to get through 1, 2, or 4. The 7 here is surrounded by 1, 2, or 3. This 7 is also surrounded by 1 and 3, specifically to get out. So let's mark these red and blue. That's not very helpful. Let's mark these blue and pink, actually. The 9s have to be different regions. We have, so in each corner is 6, 7, 8, and 9, right? The 6s are surrounded by 1, 2, or 1, 2, 4. The 7s are surrounded by 1, 3, or 1, 2, 3. The 8s are surrounded by 1, 2, or 1, 2, 4. And the 9s are surrounded by 1, 2, 3, or 2, and 3. That means to connect to each of the cells, no matter which ones they are, they must go through 1 through 4, period. That means the 8 has to be next to the 4 here. And it cannot be 1, 2 here. Because we have the 9s are next to 1, 2, or 3. Guaranteed. The 7s are next to 1, 2, or 3. Here. Or 1, 3, and 1, 2, and 3. And the 6s would be next to 1, 2, and 4. So the 8 here has to match this 6. So that's actually probably a better way of doing it. So we're going to make this red and this pink. This red must go through a 4 to reach the 6 here. Because if it doesn't, the problem is you would have this 8 connecting to the 7 and the 9, which would require 1, 2, and 3 to be used in the region because they're sharing an edge only with 1 or 2 here, 1, 3 here, 1, 2, or 3 here, 1, 2, or 3 here, and 2 or 3 here. So to connect to the 6, it has to go through a non-1 or 2. So these are the same region. This pink must be in the same region as this. So this must be pink going that way. Therefore, there's a border here, and there's a border here. We need access to a 5. So pink has to either go... It can't go through 1, 2, or 4 here. So this one cannot go through here. So it's blocked off here. It has to go... It could go through this 7. But if that's... And then that's the case, it has to go around that way. This red, then... So this pink has to essentially somehow block off here. So it could go that way. So this red must connect to a 7. If it's, say, this way, I guess it could connect this way. Hold up. This red cannot go through these cells either. Because it's not part of connecting to the 6, 8, 7, or 9. 6, 8, or 9 here. Sorry, 6, 7, or 9. 7, 8, or 9. Sorry. This red already connects to the 4 here. It has to connect to the 7, the 8, and the 9 through 1, 2, and 3. Therefore, it cannot go through here. So it either connects this way or it connects this way. It must then go around from red this way. So it's either through here or through here. It could be through the 9 this way. We don't know. Ah, but it can't go through all the way through. It connects just through the 9, and then it has to connect through spaces, right? So it either connects this way through the 9 for the red. Okay. Yeah, so how is the pink going to get through? The red has to also get through, and it can't get through 9 except through this way. So the red, how does it connect to the 9? It can't get through here because that's 1, 2, 1. And to get connect to the 7, 8, and 9, you have to go through 1, 2, 3. So therefore, cannot go through any of these. It can't go through here for the same reasoning. So the only way, it can't go this way. So therefore, it must go this way. So it has to go this way. How is the pink going to connect to the 9? It can't go through any of these. It can't go through here. It has to connect through here. So it must connect through the 2. It must go through space because it needs space around here. So this is by itself because we don't have access to a 1. This is a border. The red has to go through here. That means pink has to go this way. Pink cannot go through 1 because it needs to go through 1 to get access the 7 or the 9. So it has to go this way, which means red has to go this way. Because there's no other space for it. This is the second 1 by itself. So this is done. The pink needs to go through here because it can't go through 1 or 2, and then it must access the 5. It cannot access the 2 here because of boundaries. Can't go through the 1. Can't be through the 2 because of the 2. Then it must connect to the 9 this way. And this red has to go through this way. To connect to 9, it must also connect to a space to get to the 8. So it has to go this way. So this is red, which means that's red. We don't need these numbers anymore because we sort of figured everything out. So this is done this way. We have all those singleton 1s we need, so this has to be with a 1 and a 2. So this is its own region. This is its own region. Guess it could be yellow also. This is bounded here. Boundary here. This becomes a 1, 2 pair here. This it could be 1, 2, and 3. Actually, the 3 needs access to 2 and 1. It cannot go this way because it will block off the red from the red here. So to access this, it has to go all the way there. So this is a boundary here. Cannot access 1, cannot access 4. Cannot access 3. So the red region has already got a 1 and a 2 and a 4. So if the red connected to here, it would block off the pink region from itself. So that's not allowed. So it must connect through here. So this is red that way. It has to go that way because it does have access to a 5, so it doesn't actually have to go through here. But it needs 3 and 7. We have 1, 2, 9, 8, 6, 4. 3 and 7, we need access to a 5. If it has access to this 5, the problem is that would block the pink from pink. So this must be actually red. That means this is done. The pink has to continue on. Cannot conduct to the 1 because that would be its own region. Or, sorry, that cannot connect to the 1 because it needs to access the 1 through the 7 through the 1. So these must go this way, which means it must go this way. It can't access 2 or 5 anymore, so it must go through here. It has to connect that way. So we have 1, 2, 3. So again, this cannot be connected to this because of the 1 required for accessing the 7. So this red must go this way. So the red is all done. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's all done. This is a region. This is a region. This 3 needs access to a 2 and a 1, so it must be these two, which means that's a region. This 2 needs access to a 1, so it must be that one. So that's a region there. So this 5 needs access to a 4, 3, 2, 1. The only other 3 is here. So it must go all the way around here and then through here, because there's no other way that that can connect. So this is done as a boundary. And this is a region of yellow. And this must be a region of yellow. And these must be pink. And those are all the regions that we have. That's a solution. These are the regions of 1 each. We have one for the red, 1, 2, 3, 4, 5, 6, 7, 8, 9. For the pink, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have a 1, 2 here, 1, 2 here, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, and a 1, 2, 3 here. And then for the green region, we have 1 through 5. So that's how you solve this Ichikara puzzle. Pretty interesting, actually. I'm getting used to some of the sort of deductions that you have to make to connect these regions. There's a lot of interesting little bits and pieces which you have, which force you to connect in certain ways. Anyways, I hope you enjoyed that solve, and I'll see you next time on Frank Puzzles. Take care.